Hi there, Mr. Sutton here, bringing you the AB Calculus Derivative Extra Practice number 3 solutions. For this one, we're going to need to use the chain rule. We have ln of something as the outer function. Taking the derivative of that is going to be 1 over the something, 1 over secant of x plus tan of x. Now we have to multiply by the derivative of the something. Derivative of secant is secant of x tan of x, and derivative of tan of x, we're going to be adding secant squared of x in there. For this one, we notice that we have a variable in both the base and the exponent, so we're going to have to use logarithmic differentiation. We'll start by taking the ln of both sides of the equation. On the left side, that gives us just ln of y. On the right side, that's going to pop out this arc sine of x term, and we're going to multiply now by the ln of the base here, so that's going to be ln of 3x. So for the left side, and in general, we're implicitly differentiating. So on the left side, we have 1 over y, dy over dx, because we just took the derivative of an inner function of x. Y is being treated as an inner function. On the right side, we use the product rule. We have arc sine of x and ln of 3x, and I'll just use the box over here to organize all of this. Derivative of arc sine, that's 1 over the square root of 1 minus x squared. For ln of 3x, that's a chain rule. We have 1 over something for the derivative, so 1 over 3x times the derivative of 3x, which is 3. Now multiplying this back out, this is going to be ln of 3x over radical 1 minus x squared for the first term. And then going the other way, we can call this arc sine of x over x. 3's will cancel there. Now we have to isolate dy over dx, so we do that by multiplying both sides by y. That gives us all of this stuff in the parentheses with a y outside. And they didn't say to put it in terms of x, so you could actually leave the y there. But if you wanted to, you could replace y with 3x to the arc sine of x. On this problem, we're going to use the chain rule to take the derivative. The outermost function, we have something squared. Derivative of that is going to be 2 times the something, 2 times cosine of 4x. And then we're multiplying by the derivative of cosine. So that's going to be cosine of something right now. Derivative of that is negative sine of something, the something being the 4x that's inside there. And then finally, we have to multiply by the derivative of the innermost function, 4x. That's going to be just 4 for our tail. On this one, to take the derivative, we're going to use the quotient rule, u prime v minus uv prime over v squared. And there are things you could do to kind of sort of simplify this beforehand, but none of them end up saving you that much time. So we're just going to dive straight into this. I'm going to use the box and ribbon to organize things. So for my numerator in the upper left here, I've got e to the x minus e to the negative x. In the upper right, the denominator, e to the x plus e to the negative x. And now the derivatives of these, for this first one here, this is going to be e to the x plus e to the negative x. And over here we have e to the x minus e to the negative x. Multiplying that out now, big fraction time. These two terms here are exactly the same. So this is going to be e to the x plus e to the negative x squared. Going the other way, we have e to the x minus e to the negative x also squared. And then finally, we're dividing by e to the x plus e to the negative x and squaring that. So there we go. For this one, there's a few ways you could go on this one. One way to do this would be a chain rule with a product rule kind of inside of it. But another way you can do this, if you use some log rules, you can actually split up this multiplication using ln. We can write this as ln of x plus ln of radical x squared plus 1, because logs turn multiplication into addition of logs. And then I can go a little further here. The square root is really the 1/2 power, so I can avoid a chain rule by just popping that out as a 1/2 in front of that second ln. And now that I've done a little log simplifying, I'm just going to go through and take the derivative as normal. So derivative of ln of x, that's going to be 1 over x. Derivative of 1/2 ln of x squared plus 1, while this is a little bit of a chain rule, we have ln of something. Derivative of that is going to be 1 over the something. So in this case, 1 over x squared plus 1. We have a 2 down there, so we'll write this as 2 parentheses x squared plus 1 in the denominator. But now I also have to multiply this by the derivative of x squared plus 1, which is going to be 2x, which I'll put in the numerator. For this problem, before I try taking this derivative, which is going to require a product rule, one thing I can do to maybe save myself a little bit of a chain rule is I'm going to rewrite this 1 over 2x as 1/2 x to the negative 1. All right, so let's go through and use our product rule now. U prime v plus uv prime. Box and ribbon time. We've got a factor of x squared and another one of sine of 1/2 x to the negative 1. Derivative of x squared is 2x. This is a chain rule involving sine now. We have sine of something. Derivative of that is the cosine of the something. But now we have to multiply by the something's derivative. So that's going to be negative 1/2 x to the negative 2. And now it's time to do the ribbon and put it all together. So we've got y prime equaling 2x times sine of 1/2 x to the negative 1. That's u prime v right there. And now for uv prime, that's going the other way on the ribbon. We have x squared times all this stuff with cosine. And this one's done. To make our lives easier differentiating this problem, I'm going to use some log rules in the exponent here. We know that ln and e cancel out, so I could write this as just y equals x to the 8th power. And now this is just a simple power rule. The derivative is going to be 8x to the 7th. To take this derivative, I just need to use the chain rule. My outermost function, I've got something squared because the secant happens before we square things if we were to plug a number in here. So we've got something squared's derivative, which is going to be 2 times the something to the first power, so 2 times secant of radical x. Now we have to multiply by the derivative of secant of radical x. Well, this is another chain rule. We have secant of something. That derivative is going to be secant of something tan of something, radical x being the something in this case. Finally, we multiply by the derivative of the something, which is just x to the 1/2 power. So that's going to be times 1/2 x to the negative 1/2. To take the derivative of this problem, I'm going to need to use the product rule, u prime v plus uv prime. So I've got my box and ribbon here, and my two factors, x and ln of x cubed, or ln cubed of x. Now for x, the derivative is just going to be 1. For this next one, though, we have a chain rule going on. The outer function is cubing. We have something cubed. Derivative of that's going to be something squared, or 3 times something squared. So this is 3 ln squared of x times the derivative of the inner function ln, which is going to be 1 over x. Now so we've got ln cubed of x plus 3x ln squared of x times 1 over x, or however else you want to write that multiplication, and this one's done. To take the derivative on this one, we're going to have a little bit of trouble trying to isolate y, so instead of doing that, we're going to use implicit differentiation. So now whenever I take the derivative of y, I'm treating y as an inner function of x, so I'll have to multiply by a dy over dx tail. So going from left to right, we've got 5y to the 4th times dy over dx, there's that inner function tail, equals, another power rule here, this is going to be 140 x to the 19th, and this is going to be minus 7 dy over dx. Next, we get the dy over dx's to one side, so this 5y to the 4th dy over dx can stay there. We're just going to add this 7 dy over dx to the other side, and then we'll still have that 140 x to the 19th on the right side. Now that the dy over dx's are together, I can factor that out, leaving me with 5y to the 4th plus 7 inside of parentheses. And if we divide by that parentheses, we get dy over dx. On this problem, I need to use the chain rule. So our outer function, we've got arcsine of something. Derivative of that is going to be 1 over the square root of 1 minus the something squared. Next, we have to multiply by the derivative of the something, the e to the sine of x. Well, the inner function here, this is e to the something. Derivative of e to the something is also e to the something. But now we have to multiply by the derivative of that something, that sine of x. The derivative of sine of x is cosine of x. And this one is done.